This is my take on the already highly populated brushless gimbal population. I've tried to design one that is adaptable to different configurations. So you can have a 3-axis gimbal or a 2-axis gimbal for either the Gopro type of camera or Gopro clone, or the Mobius type of camera or a Mobius clone. The 3-axis gimbal has the gimbal controller mounted separately to the gimbal. That's because I'm using the Storm 32 board here. The board has an IMU in it, and it needs to work in coordination with the camera IMU, which is there. So if I had that mounted on the back here and it moved around, it wouldn't be able to get the correct readings. I've tried to keep the wires internal so that you can have full movement of the camera in all axes, and I've used these motors, which have a hollow shaft, and the wires can go through the center of the shaft. The motor is the RC timer, just trying to read the number here, GBM 2804 D19 100T. So it's a GBM 2604 D19 100T. They're available from Far Eastern suppliers like Banggood and eBuyer. They don't seem to be available in the UK. I don't know why not. Right, so you need to make up your mind whether you want a 3-axis or a 2-axis gimbal, and for which camera you need it. If it's a 3-axis gimbal, then you need to download the parts for a 3-axis gimbal and any parts that are specific to your camera. All the files are on Thingiverse and you can print them out. The 2-axis camera, the 2-axis gimbal has the BGC brushless gimbal controller mounted on the back of the upright there, and that doesn't move with the gimbal because there's only 2 axes. The assembly is straightforward. You download the parts. Here, for example, is the upright for the 2-axis gimbal. It's got the mounting for the gimbal controller. Either an Lexmos or a Storm 32 board will fit there, or any board that's got a 50mm profile. And the wires for the, let's get another arm now. Here's a roll arm from one of them. The motor goes into this sort of cup arrangement, and it only mounts in one direction. The motor leads go through the arm, just try and show you that, through the arm like that, and the motor is screwed in like that. Now the holes for the motors are polarized, they're different on each end. On the back end they're offset, so the motor will only screw in one way at the back, and that is the way in which the lead comes straight out through the arm. And if you find that the holes don't match up, then you've got the motor in the wrong way. So just turn it around a bit until the holes do match up. When they do match up, then you've got the motor aligned in the right way. The motor leads then go through this groove and through the center of the next motor, and so on. So that's the way the wires go. If you look a little bit more carefully, I'll try and put some diagrams of how these wires go. Look a bit more carefully at this one, for example. The leads for the IMU go through this groove here, through the center shaft of that motor, through the arm, through the center shaft of that motor, through the arm, through the center shaft of that motor, to the brushless gimbal controller. And similarly the wires and any other leads for the motors. Now you don't have to do it like that. It is said that the BGC has some problems with the I2C bus. If you have that problem, you might like to keep the I2C wires, the IMU wires, separate. I haven't had any particular problem with that. It seems to work okay with the IMU wires going through the hollow shafts. Perhaps there's some shielding inside the shafts, I don't know. But that's fine. If you do have a problem, you can keep the IMU wires separate. Just keep them coming straight from the brushless gimbal controller to the IMU. Or you can, I believe, not use the I2C bus at all and replace it with the, what do they call it, the NT bus. And you can use an NT module for that. I haven't tried that myself. I'm going to run a few experiments. Apparently you can use the CC3D module as an NT module and use that as the IMU. And if you do that, you won't get any problems with I2C errors. Well, I can't say whether you will or you won't. I'm going to give it a try and maybe put another little video up about that. So there's all sorts of different parts. You just need to download the parts for the gimbal that you've decided to make, whether it's 2-axis, whether it's 3-axis, whether it's for an upright camera like the Gopro, or a flat mounted camera like the Mobius, or this thing, the Foxeer Legend. I haven't tried that yet. It looks like quite a good camera. And you can download different parts. You can have a base that doesn't have a mounting for the gimbal controller, a base like that, or you can have a base that does have a mounting for the gimbal controller like that. Also, these are configured for the DJI type mountings that you can buy quite cheaply. Dampers, DJI dampers. I don't know if it'll fit other dampers. I should imagine it should. But there you go. I'll just plug in one of these gimbals and you can see if it works. Let's plug this one in. It's got a Storm 32 gimbal, which takes quite a long time to initialize. So there's going to be a bit of a pause here. I might cut the video. Plug it in and it finds its level, hopefully. There's the beeps, it's found its level, and now it should stabilize. There's the pan movement. You see there's a lag in the turn. It stabilizes the pan, stabilizes the tilt, and stabilizes the roll. So there you go. Oops. I'm not sure whether the Storm 32 is the best board to use for this. I've had more success with the Lexmos one. The Storm 32 board I found to be a bit quirky, but your mileage may vary. Anyway, I'm using Storm 32 boards for these, and it seems to work. There you go. What I haven't mentioned is that, of course, these gimbals can be copter mounted. In other words, hang down below the copter. They work just as well, and the 3-axis as well. And they are, oops, let's get around the right way. They are drilled for normal rail mountings for quadcopters, multicopters and so on. As well as that, you can also configure the gimbal, the 2-axis gimbal, in a way that the 2 axes are just the pan and the tilt, and the roll axis is fixed. Why would you want to do that? If you're flying fixed wing and you're using head tracking, you want to be able to see the roll axis, so that's fixed if you're flying the plane through the camera, and your head will track pan movements and tilt movements, so you can look around out of the aircraft as you're flying. I find that quite useful, and I tend to do more fixed wing flying than quadcopter flying. So that's the configuration that personally I prefer. I don't think there's anything else to add really. Thank you for watching the video.